Hello and a warm welcome to everyone joining us today. I hope you're having a wonderful day so far. Today's session is going to be all about how DDI solutions scale, secure, and simplify university LAN operations. So we all understand the physical campus footprint, multiple zones, multiple buildings, mixed endpoints, constant churn. But the real stability of a university LAN comes from the invisible layer, logical control. This layer is responsible for mission critical IP communications. It assigns addressing, pushes the right network options, maintains name to IP reachability, and ensures availability even during churn, onboarding spikes, and failures. DDI, which is DNS, DHCP, and IPAM, forms the core of that logical layer. When they are integrated, you can treat campus operations as a controlled system, segmentation by role and location, policy-driven IP allocation, controlled DDNS updates, and high availability for both leasing and resolution. In this session, we'll share practical glimpses of how this is operationalized using ManageEngine's full stack DDI solution, DDI Central. So the logical plan stays aligned with the real campus reality. So I'm your host, Akshara GJ. I'm a product expert for ManageEngine Cloud DNS and DDI Central. My focus is making complex network infrastructure simple, secure, and scalable, especially in environments where scale is not optional, and campuses are exactly that environment. Today, we'll cover four things. First, how to segment a distributed campus network across buildings, labs, and user groups without adding complexity. Second, how DHCP and IPAM policies automatically assign configurations. Third, how to enforce security at the foundation, at the DNS, DHCP, and IP level. Fourth, how to scale confidently while reducing manual effort. A campus environment is busy. Physically, you see movement like students, devices, classes, labs, but logically, the control layer must remain calm. Every endpoint needs identity, every system needs reachability and availability. And the DDI control layer must remain visible, operable, and resilient regardless of the churn. Have you ever wondered how your laptop gets an IP address? You plug in, DHCP assigns configuration, DNS registers the host name, IPAM applies the policy and tracks usage. This invisible process powers every login, every lecture stream, every CCTV feed in milliseconds, every time. Every device's life starts with three questions. Who are you? Where do you belong? What can you reach? DHCP establishes that identity. IPAM defines placement and segmentation. DNS enforces reachability and access. And DDI answers all these three questions automatically at the moment of connection. In many campuses, DNS, DHCP, and IPAM operate independently. This creates the drift. With gaps and manual overhead, this creates the confusion. In DDI Central, they behave as a single policy-driven control plane. So therefore, there's unified automation, unified audit, and unified governance. So how does a campus LAN handle everything without falling apart? Let's zoom out for a second and look at how a campus LAN can accommodate everything. A university network isn't hard because of Wi-Fi coverage, it's hard because of constant churn. Students, guests, labs, printers, CCTV, IoT dorms, everything moving, changing, and still needing to work. And the hidden truth is every single endpoint triggers the same four decisions. Where does this device belong to? That is segmentation. First, we decide its neighborhood, the right VLAN and subnet by building, department, and device type. That's how we keep the blast radius small, so student churn never spills into CCTV or admin networks. So with the next operation, the configuration, what should it receive? Next comes DHCP. So DHCP doesn't just hand out IP, it hands out the device's network personality, its gateway, DNS configurations, options, lease time, and more. Stable devices get reservations and longer leases, like printers, CCTV, and access with greater access controls. And high churn zones like DOMs and guest Wi-Fi get shorter leases and tighter controls. Next decision is resolution. How does it stay reachable and secure? Then we make it reachable by its name, DNS plus controlled DDNS, and also with Active Directory regulated domains. This is where reliability and security meet, keeping name to IP accurate as devices roam across different IP segments and enforcing policy at the DNS DHCP layer to prevent hijacks and misdirection. Because if DNS lies, everything downstream breaks, like authentication, LMS, printing, labs, and surveillance. And with assurance, how do we keep it always on? Finally, we make sure this survives failures with DHCP failover, redundant DNS, and continuous monitoring. Not just uptime, change tracking too. So, with record history, audits, and visibility into what changed and by who and when, the real problem on campus connectivity is solved. So it's not about connectivity anymore. It's about control at scale. And that's exactly why DDI exists, because it centralizes these four decisions and keeps them consistent across the entire environment. Before DDI Central, operations meant scripts, lots and lots of scripts. So even for a single configuration, they have to push 100 lines of scripts. So there is manual scope duplication, configuration drift, and stale DNS records. After DDI Central, it's all about click and play. So it's centralized policy, controlled DDNS, and full audit visibility. You standardize all these policies once and scale everywhere. Campus, segmentation isn't hard to draw, it's hard to operate. Segmentation should not multiply work. You segment by intent, by building, by lab, by user group. You define the behavior per segment and the system enforces it consistently. With failover ready scopes, predictable IPs, and a clean structure, you get a whole segmented network. So there is clean segmentation, consistent policies, and your network works smoothly, accommodating the right devices. So let's see how this is accomplished in DDI Central. So here in DDI Central, we have within the IPAM, we have something called the IPAM tower. This is not out yet. It is still in testing, and I'll be showing you in this webinar session here for the first time. And here, when you import all your configurations inside DDI Central, it is cataloged under this IPAM page, which is called the IPAM tower. And here you'll be able to see the site view, cluster view, and the supernet view. All the regional sites that you have, all the location-based configurations that you have, you can view it under the site view. So this is location-based classification, and within this location, you may have many managed groups of servers that you can logically group it as clusters, and within the clusters you will be able to see all the managed subnets, all the IP space that you manage under DDI Central. And with the supernet view, you'll be able to break down your IP space in a hierarchical order, and you'll be able to track them down by clicking it one by one. And you can have a tree-like structure, or if you're more into cards, you can tune them as such. So we have different views here, so you can track them down. So before we move into this visualization zone, this was possible only because the creation of subnets, clusters, and sites were possible. So here first we create the site. So when you create a site, you'll be able to see what are all the clusters that you can accommodate in this site. A site can have as many clusters as you want, and so when you accommodate the clusters, when you accommodate the clusters in a site, it creates a one-on-one association. So you all the subnets under the clusters are listed out here, so you can easily track them out. And with the cluster view, you can create clusters. So let me show how a cluster is created. This is the basic configuration actually. First, when you enter DDI Central, you'll be asked to onboard your servers. First, create a cluster and then onboard your servers. So for creating a cluster, you need to create click on add cluster, name your cluster, select the type of OS and select the type of services. And you can also specify the site if you want, and then you can save the configuration. Immediately, if you have many clusters, all the managed clusters will be displayed over here. And if you have servers to onboard, the next step would be onboarding servers. So you'll click on this add server, you'll be automatically directed here. But if you have the servers by clicking on add servers, and you'll be entering all the essential information and you'll be onboarding your servers. So once the server is onboarded, it'll start the discovery, or you can start setting up the configurations. So let me quickly drift into DHCP, where you'll be building your IP space. So these are the building blocks with which you will be building your IP space. So here's the subnet, static subnet, shared network, and client class is basically the policies. So here with subnet, you'll be mentioning the network address, and we follow variable length subnet mask. So you can mention any prefix you want. And if you are not sure about the subnet boundaries and all the IP ranges within the subnet, you can mention the subnet prefix, and you can use the subnet calculator to calculate the IP ranges within the specified prefix. And if you like to associate it with a DHCP server, you can very well do it, or you can associate with a failover configuration of DHCP servers, and you can keep it as a standalone, or you can put it under a shared network. And you can also configure it under a supernet to have a hierarchical structure like this. And then you can associate it with a site, or if you'd like to manage this subnet as a VLAN, you can very well enter the VLAN's details and you can save it as a VLAN. So when you do this, a subnet is automatically created. Whenever a subnet is created, you can also associate the DHCP options that come along with it. And also you can define your own custom options and associate with a subnet. So along with this, we also have something called static subnet, which is the IP space that you not want the DHCP server to not interfere with. So here you can manage all those critical devices that you'd like to manage manually. So here you'd be uploading static leases that you manage in a spreadsheet, or you can just create a static subnet from the DDI Central UI, and you can start managing them. So we have automatic ping checks. So we'll be informing you whenever the device associated with a particular static subnet is down, or if it's available. So you always get prior information. And then we have the DHCP reservation here as hosts. So if you have certain hosts with fixed IP, you can create them automatically with add host, and just make sure you mention the MAC address of the host and give it a fixed IP. So you can position it as a standalone reservation, or under a subnet or a shared network or a host group. And you can assign the options and custom options accordingly. So this is how you create the boundaries, you create the building blocks. And how the next step would be how you accommodate all these. So with this DHCP scopes, you create with the DHCP scope manager in DDI Central, you create the scopes fast and you delegate them safely. So you have role-based access controls as well for each of the scopes, and all of that gets, all the activities that you perform in here is audited. So for each scope that you create, each element that you bring to life, everything will be audited in the DHCP audit logs. So you can see what subnet was created, whether it was created using API or via the UI, and all of the pool data that was processed, everything will be shown over here. So instead of scripting scope after scope, use standardized ones and scale everywhere. That's the magic that a DHCP scope manager has. And if you have universal global options and custom options, you can very well go get into config page, and you can start adding the options. So the options that you create here or add over here is universal for all the clients joining your network. So now we talk about the policies that define who should be accommodated where and what configurations they can receive. So for this, we have DHCP fingerprinting policies or DHCP policies. So here the IP assignment is an identity decision, and this is taken charge by the DHCP server. And if it needs a host name along, the DNS server also participates in this operation. So the IPs aren't handed out randomly, they're assigned by policy based on who and what is connecting. So let me show how this is configured inside DDI Central. So for this, let me show with a Windows cluster as an example. And for this, we'll be getting into the DHCP module, and we have something called DHCP policies. So we have something called policies. And here in this policy, you'll be, whenever you want to create a policy, it'll ask you if you want to associate this policy with a DHCP server or a subnet. Okay. So in Linux, we have it as a client class. So you can just add a client class of your own, and you just mention the class name and keep it as a standalone policy, or you can put it under a subnet. So it specifically applies to that subnet, and you can specify the range, IP range from which the policy should be, the policy applies. So if a certain device satisfies a criteria mentioned in the condition section over here in this policy, the device receives IP addresses from the specified range that you select over here. So you can allow this range for a certain device, or you can totally deny this range for the devices that satisfy a conditional criteria. You can just get into a traditional ISE format for mentioning the condition, or you can just choose our easy to operate templates. And here you can mention the match type, whether it's going to be a substring or a prefix or a suffix, or it's going to be option based or configuration option or a hardware based match type. And you can specify the other configurations, offset, length, and everything, and you can specify the exact match string and match value over here. And so, and you can assign DHCP options that are specifically particular for this client class, and also the custom options even. So that's how you create the policy, and all the devices that satisfy this conditional criteria over here get IP addresses from this specific pool. So that's how the DHCP policies work. So you don't get a random IPs, you get subsequent specifically chosen IPs and configurations based on the identity and based on the device that is joining the network. So this is accomplished with DHCP fingerprinting, where we treat devices differently by design. So it's just the same LAN, but different behavior. A student laptop receives a standard lease. A CCTV device receives a reserved IP on restricted options. A printer receives fixed reservations and custom DNS. A guest device gets a short lease and isolated range. So DHCP fingerprinting allows differentiation by design. And the other thing that is very unique to DDI Central is creating configurations on schedule. So the campus runs on schedules, right? So should your network. So when there are exam weeks and there are hostel onboarding and there are maintenance windows, you would need special configurations, and you would want the admin to stay close by to look after these configurations. But this is practically impossible, right? You may have universities running on the weekends, and you would not want the poor admin to work 24/7 even on the weekends. So in that case, we have this scheduled configurations where whenever you create a scope, we also ask you for an option whether you want to, or a policy, even if while creating a client class, we ask you an option whether you want to make this configuration go on a schedule. So when you enable this, you'll have to specify the date and the time when this configuration has to go live. So when you choose this, you can only when you set a particular configuration on schedule, when DDI Central has registered a certain configuration has to be scheduled on a certain date and time, you cannot make any configuration changes later, because when it's on a schedule, you cannot disrupt the changes and disrupt the configurations inside, but you can change the schedule of the configurations inside. So you can just reschedule it, or you can make changes to the schedule, but not the configurations that you've already set up in that scheduled configuration. So that's the only thing here. Or if you want a complete changeover in the configurations, you'll have to delete the schedule and you have to create it back. So this applies to even DNS records even. So even if you want to create a DNS record on schedule, you can just add a DNS record and you can put it on a schedule. So even if on the weekends, if a certain zone or a record has to go live, this can be done smoothly within DDI Central. So timed configurations go live when you say so automatically. So there's no midnight manual changes. So every updates in your DNS, in a user joins the network, they also get IP address as well as a host name. So all this has to be automatically done, and you cannot be waiting for an admin to do everything. So we have dynamic DNS and AD regulated domains for that. So they take over these automations, and these automations are trustworthy as devices come and go. So your network works like a well-oiled machine without any manual intervention. So that's why DHCP and DNS updates that's how they maintain accurate name to IP mapping, and reduces tail records and ghost endpoints, and controls who can update and what with all the guardrails implemented. So let me show how DDNS is done. So when you get into the DNS module, and if you want to create a new domain, you can create a domain by giving all the essential details and enable DDNS for it. And it will ask the DHCP service that you'd like to work along with this DNS, and you can specify the DHCP services, and you can assign specific DNS options, like how the updates has to be operating on. So we have specific options for it, and you can assign that. And with AD directed domains, let me show you with a Windows cluster. So let me get into a Windows cluster, and you can create a new domain. While creating a new domain, it will ask you if it's going to be an AD directed domain, AD directory domain. You can just give the replication scope that you prefer, and you can specify how the dynamic updates should take place. And when you create this, it makes sure to update the IPs from its network address of the domain controller, and you can add the primary and secondary controllers over here, and you can mark the primary domain controller in the settings option over here. So here you mark it as the primary domain controller, and so as and when the updates are created, the stale records are also created. For that, we have the scavenging option over here. So let me take you to the scavenging option. So you can configure the scavenging on schedule, or you can scavenge it right away. So when you create a schedule, it'll ask you for the scavenging period, the aging criteria, whether it's going to be 7 days or 14 days. You just have to mention this for all the records, and for the TXT records specifically, which is most probably used by all those malwares. You can just specify the scavenging period, and you can specify the schedule interval. So what happens, and you can specify the domains on which the scavenging should be applied. So when you do this, what happens is you get a complete list of stale records here. So when you get in the scavenging model within the DNS, you get a report of all the stale records within the um, all the stale records within the cluster, and you get something like this. With all the stale records here, you can immediately purge them, or you can set. So as it is shown over here, a schedule has been configured, and you get a report along that which shows you all the stale records. Here you can immediately scavenge now, or you can scavenge them on schedule, or you can immediately purge them using the option over here, or you can reclaim them as and when required. So that's how we keep the DNS clean with DDNS and DNS scavenging. And to automate the PXE boot process, we also have templates. So here you automatically fill in the details, and you can set the PXE boot policy in action. So here we will get into the templates that we have within the Linux cluster. So here we have the DHCP module and the client class. So we have, you can also create templates. So here we have the client class for PXE clients. So here you'll be mentioning where it should be positioned and all, and the scope of the policy, whether it's going to be for a particular subnet or it's a standalone policy, and you mention the range, and also you specify the match type, and here you give it as substring and offset values and everything. So you identify the vendor class identifier, and based on the architecture code, if it's a particular architecture code, you direct it to a TFTP server. So here we mention it as a DHCP option. The option is next server, which is nothing but a TFTP server that the client that satisfies a conditional criteria must go to. And then if it goes under a particular range, so if the client falls under a particular range or a subnet, this policy, the PXE boot policy, directs them to a particular TFTP server, and within that TFTP server we give the file path. So there we can branch out this condition with the if else structure over here. So you can for different OS you can give the boot files here, so you can re-image your devices without any manual intervention. So your admins do not have to work on the weekends and for re-imaging the lab devices. So there can be even 300 systems that has to be re-imaged, right? So in that case, it should not require 300 hands or 300 hours. So it should be auto-enabled using the PXE boot templates in DDI Central. So you can roll images quickly for labs, kiosks, and shared system, and switch back automatically after deployment window closes. So here you set it up just once, and DDI Central will handle the rest. Amidst all these quick automations using a DDI solution like DDI Central, we also have this pressing need for pervasive security. So the campus is a high value, high exposure target. So defense must begin at the control plane. Before we talk controls, here's why universities are such a unique security environment. They get hit a lot and the impact spreads fast. According to the government of UK, over the last year, 91% of further and higher education institutions reported a cyber breach or attack. That's not some, that's basically the sector. And it's not occasional. Among those that had incidents, 30%, 30% of the said attacks happened at least weekly. So, for many campuses, this is not an emergency event, it's a recurring condition. So, what's driving a lot of that volume? Phishing. 97% of institutions that had incidents reported phishing attacks. So, the front door is still human trust, students, staff, faculty. Now, here's the part that matters for network teams. When ransomware does land, the blast radius is huge. According to Sophos, in higher education, about 50% of computers are impacted on average per incident. So the takeaway is simple. Universities face high frequency plus high spread. That's exactly why DNS DHCP becomes strategic because it's one of the few layers that can see and contain early movement across the environment. Now let's quantify the fallout. In higher education, the mean ransomware recovery cost was reported at 4.02 million, and that's excluding the ransom payment. So even if you never pay, the recovery bill still hurts. Downtime, rebuilds, incident response, and operational disruption. And the initial entry path is consistent with what we all see: social engineering. Verizon's 2025 DBIR reports social engineering accounts for 16% of breaches in educational services. That maps perfectly to the real campus threat model: high trust, high churn, and lots of identity workflows. Finally, when exposure happens, higher education tends to carry a heavier data footprint. One report cited 3.7 million records breached in US higher education versus 175K in US K 12 in 2025. So the story across these numbers is they get hit often, the damage spreads wide, and the recovery cost is real, which is why our focus today is practical: how DDI led security controls and helps you reduce the blast radius early without disrupting uptime. A 2023 academic research reinforces this pattern. The key point is this: campus cyber risk isn't one problem, it's a convergence problem. Up top, you've got the usual external pressure: phishing as the entry point, ransomware as the monetization path, and a steady rise in attacking volume. Down below, you've got what makes universities uniquely difficult: student actions, huge device churn, unmanaged endpoints, constant onboarding, staff actions like privileged workflows, admin systems, and research access, and DDoS because universities are public facing and disruption is cheap. And all of that funnels into one outcome: university cyber threats are in high frequency and high impact and hard to contain because the environment is open by design. So, why am I showing this in a DDI session? Because across all these attack types, phishing, ransomware, DDoS, and internal mistakes, there's a common dependency. Every path still relies on DNS to reach and DHCP to exist on the network. That's the lever here. If we harden DNS DHCP as a governed control layer, we are not solving one threat, we are reducing the blast radius across many. So here's the uncomfortable truth: if the attackers steer either DNS or DHCP, they steer everything. Every device asks DNS where to go. DHCP decides who joins and what configurations they receive. If you don't control the resolver and the lease, you don't control the blast radius. Breaches often begin because DNS and DHCP lack a central security brain. Rogue services rewrite reality, unknown threats go unnoticed. Without correlation, you cannot act decisively. Fragmented logs eliminate accountability, and roaming users amplify risks. Now, so this brings us to the other part where there is a control plane drift. So with there is when the direction gets easily manipulated, identity gets blurred, and response gets delayed. If DNS and DHCP aren't governed centrally across a centralized control plane, attackers exploit this inconsistency and live in the gaps rent free. So why there is a need for correlation? If you cannot bind query to lease to device to user, you cannot contain. DDI Central correlates IP, MAC address, host name, DHCP lease history, DNS history, everywhere users connect. So this correlation turns alerts into errors. So this is DDI Central's way of approach towards offering a wholesome DDI security. So we've built this defense in depth security stack. The first layer is the DNS firewall, which blocks all of the known threats. Here you'll be building a block list. Let me show you the block list that you get to build. So you'll be managing all those known malicious domains in a block list over here. And if you're not sure about the subdomains that exist below it, you can just check this blocks of domains checkbox over here. And you can also give a redirection IP whenever a user is trying to access one of these domains. And if you have many number of such malicious domains, you can import them as a CSV file. So this is okay if your university is network is bit small, or if it's a single building, and if you have a low volume of users, devices, and everything. But this does not work on scale. The DNS firewall, you need more intelligence. So that's why we have the threat intelligence module. So this gives you real-time global awareness. So if anywhere in the world a threat is detected, it's updated to you using the threat feed. And with anomaly detection, you have ML driven behavioral screening that does true magic in bringing out the unknown threats to the fore. And the final layer, the DNS detection and the response layer, helps you contain these threats without any manual intervention. So let me quickly go through the layers one by one. So with DNS firewall, you get response policy zones which helps in custom redirection. Not necessarily you give a 404 or forbidden, you just give a custom domain name and you get them to a safe portal. And with response rate limiting, if DDI Central finds a DNS amplification attack in progress, we have response rate limiting controls to throttle such query amplified queries to the your infrastructure. So we have response rate limiting over here. So you can also add an exception list if you have trusted sources making high volumes of queries. So with DNS rate limiting settings, you can configure how many responses per second should be given in case the volume of queries go in an uncontrolled way. In that mode, you can just we have certain presets as well. With those presets, you can set up the responses per second. If it is from a specific prefix length, you can throttle that with our response rate limiting settings, and that's how that can be throttled. And we also have security analytics to help you find out, pinpoint who's accessing what and who's um, disobeying all those who's accessing all those malicious domains. You can easily pinpoint that with our block domain analytics. You get to see who and the number of queries to those block domains in the firewall's block list, and also in threat analytics, threat intelligence feed in engine. So you can just get over here and you can see what are all IPs that were accessing the block domains and how many queries they made and what are all the records they accessed, and everything can be seen over here. Basically, you get a view like this where you get to see the IP, and also the MAC addresses would be visible if they are in a lease, and you get to see all the record types they were accessing. So this is what the analytics part does. It will help you visualize and help you know who were accessing a particular domain, and gives you the whole context to it, an admin. And with the threat intelligence, your global awareness layer expands. So here we offer real-time protection. So when you get into the threat intelligence module, the first step would be you register your feed servers. So when you register a feed server, we have integrations with different vendors. If you have license with them, you can very well integrate that into DDI Central, or you can add a custom sticks or taxi server by bringing your own intelligence if you'd like, and you just give all the necessary configurations. And when the feed server is successfully integrated with DDI Central, all the feeds would be displayed over here under the feed hub with the corresponding confidence score. And if you like to customize the confidence score, you can just specify the confidence score that you'd like to block. And say if you have a confidence score like a requirement of a confidence score more than 60, so you when a particular domain name comes with a risk factor or a confidence score more than 60, DDI Central will make sure to block them right away. So that's how threat analytics work. I mean, threat feeds work. And we also have different reports that will give you analytics for each indicators of compromise or each malicious domain name. So you can see the top threats and top affected hosts, and the record type they accessed that were requested. And we just do not block the domain names. We also have the provisions to block IPs. So if they are trying to access particular IPs, they can also get blocked with threat feeds. And the next layer, which is the anomaly detection layer, which deploys ML-driven behavioral screening. This catches all the unknowns lurking in your environment without even your notice. And it detects for a suspicious patterns in the domain name, and then it looks for its behavior. So with that, you'll get to know if this is a suspicious domain or not, and then you can block it right away. So there is early signal detection over here. So it surfaces the risks long before the threat feeds can even catch up. This can be demonstrated with a use case that I'm going to discuss in the further segments. And this will give you reduced noise. So it learns your baseline, the baseline of your network, and then it will expose only the true weak signals in your network, and that too very early. And with the context rich data, it enables faster validation and shrinks the exposure window. So your DDI continuously learns, it predicts, it stops the attack before even they start. So these are the anomalies DDI Central detects, and you get to block them right away whenever a certain, so a particular domain name can have more than different anomaly categories. So the risk level for those domain names would vary and would be increasing with the number of criteria that matches with the particular domain name. So a particular malicious domain name can have DGA patterns as well as exposing DNS tunneling. So the confidence score will rise accordingly. And within the anomaly detection as well, we have different visualization tools available. So you have the insights module, which gives you the anomalies in your infrastructure, the top DNS anomalies, top DHCP anomalies, and top 5 flagged anomalies, all the domains ranked by their severity, and the top queried domains, which are malicious and everything. And you get the top suspicious client in DHCP, everything reported to you using the insights module. And you also have dedicated reports for each of the indicators of compromise that DDI Central itself detected using the anomaly detection layer. So that's available here, and you know under what category this was classified as an anomaly, and the confidence score in it. Everything would be reported over here with the reports, and you can just click on it and you can know its subdomains and what other additional information. And so let's get to our use case. So here's an interesting use case. So this is a campus story that feels painfully real. A student gets an email that looks completely authentic. The sender name is the principal himself, and the tone is very warm, official, and urgent, but not too urgent. The message says, "We are building a cross community group with nearby universities. So sign up to represent our campus, limited seats, please register today." So it's the kind of email students want to believe. They click the link, and before any login page loads, before any credentials are typed, something happens quietly in the background. Their device makes a DNS request for a brand new domain, keep your unique connected.er. So now here's the problem. The domain looks believable. It sounds like a campus connectivity portal. And when we check it against the threat intelligence feed, it's not even flagged. Not because it's safe, because it's new. The threat intelligence feed hasn't encountered yet. It hasn't been cataloged yet. It hasn't been seen enough across the internet. So that's why it's not yet in those feeds. So this is what attackers are betting on. They rotate infrastructure faster than the feeds can learn. So if your defense is only block known bad names, this click walks right through. So this is where anomaly detection changes the story, because instead of asking, "Is this domain famous?" we ask a better question. Does this behavior belong in our campus baseline? And we can flag it at the DNS layer itself before the connection is even established, or before the student gives away the credentials, or before it turns into an account takeover. Threat intel asks you, "Have we seen this before?" Behavior asks, "Should we trust this now?" So why anomaly detection layer flags it? Let's unpack why the behavior layer needs the domain on the block list. So we look at two sets of signals, DNS behavior and DHCP behavior. So that's the advantage of DDI. You're not looking at a domain in isolation. You're looking at the domain plus the device behind it. So the DNS level patterns show it's a newly seen domain. In most university environments, you have strong normal patterns. A domain that has no prior history on campus suddenly appearing from a student endpoint is a strong early warning, especially right after an email click. Look-alike naming. Attackers borrow trust words: unique, connected, login, Wi-Fi portal. The name is engineered to feel like something the university would run. Third, unusual query bursts. Many of these campaigns don't do one lookup. They trigger follow-on lookups, subdomains, tracking hosts, redirects. You'll see sudden spikes, especially NX domain bursts or repetitive patterns from a single endpoint. Fourth, fast flux behavior. If the domain starts resolving to multiple IPs quickly, and that too with short TTLs, that's classic infrastructure designed to evade reputation systems and takedowns. Now, DNS tells us something suspicious is happening, and DHCP tells us who is doing it. So we'll look at the DHCP level patterns. First, the new device or a new MAC. If this query comes from a new or rarely seen device with no identity history, that increases risks. And with abnormal lease behavior, there is rapid renewals, repeated DHCP request loops, sudden subnet churn. These can indicate misbehavior, automation, or attempts to blend into noise. And then we have starvation symptoms. If a segment starts producing unusual volume of lease requests, it's not just availability risk, it can signal an active campaign or rogue behavior. So the key point is this: we don't declare compromise from one signal, we build a case from multiple weak signals that correlate into one strong story: a believable email, a click, a first-time campus domain, a suspicious DNS behavior tied to device identity. And this gives your team what matters most: an early warning at the DNS layer and enough context to respond fast. And once you can see it, the next question becomes, how do we stop it without breaking the network? So this is where our DNS detection and response layer, or the DDR layer, comes to the fore and acts automatically with zero touch containment. So we literally arrest the devices right in the network with in following a three-pronged approach. First, we block the queries to that particular domain name and we turn our attention towards the device. So we block all the DNS queries that this device makes. The compromised device, whatever queries it makes, it's totally blocked. So it's blocked away from the internet. It cannot even access the internet. Now we make sure that the device never visits our network again by blocking its MAC address, forever. So whoever tries to access the device with that MAC address cannot even join the network. So it's totally sealed away from our network. And this is how we make the network to not even interact with our local network. So it's literally, the device is literally arrested. And with the forensic traceability that we offer, there is full activity trails that is captured automatically for every indicators of compromise. We with that reports in the anomaly detection module, the admin gets full context behind the incident and he gets to give post incident analysis, that too very quickly. So what is the main advantage here? There is a 90% reduction in the attacker's dwell time. So the attacker's presence in the network is totally shrinked away and it blocks the re-entry automatically. So what's the ultimate outcome here? So users roam, sites change, perimeters dissolve, but this centralized policy applies wherever a connection starts. Even if they connect to your network using a VPN, or if they are connecting from home with a dedicated university device, their device makes sure they do not get access to such malicious domains at whatever, however they may try, and they'll not be able to join your network if their device is compromised. So DNS decides where and DHCP decides who. With this policies implemented into your network, it enforces this centralized policies at the right checkpoints whenever and wherever needed. So DDI Central doesn't just suspect compromise, it also helps you verify it. So the Central security stack takes action. Yes, that's essential. It also has a trust layer that adds certainty. So because in real incidents, the most expensive thing isn't malware, it's ambiguity. So here's the distinction. Signed answers with DNSSEC means this DNS response is authentic, and with trusted leases, rogue DHCP detection and DHCP MAC guardrails means this device's network admission is legitimate and it receives configurations from a legit DHCP server. And corroborative device evidence from Endpoint Central helps you validate the device's story. So we don't just say this looks suspicious, we can say the answer is real, the lease is legitimate, and the device evidence aligns. That's the shift from reacting to proving. So as I already told you, DNSSEC ensures authenticity. With cryptographic proof, it validates the DNS responses were not altered. There's no silent. It stops all the silent redirection, and it all the ambiguity that comes along disappears. That secures the truth of the response. A lot of security programs can block, but when a network manager asks why you blocked, or when an incident review asks how sure you were you, or you need something stronger than a hunch, right? So this is where these three approaches come to defend you. So to prove the integrity or to protect the truth, we have DNSSEC, which gives cryptographic assurance that the answer wasn't spoofed or altered. You're not trusting DNS because it looks right, but you trust it because it's verifiable. And with the protection of admission, you have the rogue DHCP detection that confirms the server issuing the leases is legitimate. And with DHCP MAC filtering or MAC guardrails, this controls the limit who can even obtain a lease. So the identity event or the DHCP stays trustworthy. And with the corroboration, you validate the story. Now we can cross check the device behind the traffic, patch status, vulnerability exposure, diagnostics, uptime, all that is worthy of it, and we can validate all of them. So this incident isn't just a DNS alert or DHCP alert, it becomes a complete device narrative. So this is how in DDI Central, integrity, entry, and corroboration works hand in hand. So we kill ambiguity at the source with no guesswork. When a DNS or DHCP alerts fires, you don't stop at who had the IP then. We just ask how risky is the device with endpoint central integration. So you bind the IP context to patch status and CVE scores and diagnostics. So corroboration equals faster confidence here. So with the integration with the endpoint central, our IPAM became a risk-aware IPAM. So the endpoint central integration made our every IP carry the vulnerability context along with it, and address management became more of an active security layer. So on the resilience front, because for DNS and DHCP, availability is as equal as security, right? So security must survive failure. So both of these, server level HA and console level high availability, under the hood of these high availability services, are powered by Keep Alive, which is a special service that facilitates continuous health checks plus a floating virtual IP. So failover is automatic and the service endpoint stays stable. At the server level, Keep Alive monitors the active and standby DNS DHCP nodes. If the active node drops, the VIP or the virtual IP floats to the standby. Clients keep using the same service address, so the failover is transparent. At the console level, the same keep alive and VIP mechanism protects the management UI. Even if the primary console goes down, the VIP moves, so admin don't lose control right when an incident is unfolding. So here's how we accomplish this. So you can get into a dashboard and you can see how which console is working right now, whether it's going to be the primary server or the secondary server. So the primary server and the secondary server exchange heartbeats, so they are totally in sync. When the primary server goes down, the secondary makes sure to come to the fore and take over the operations. So the promise here is simple: one HA cycle, two protections, service continuity for users and continuity of control for operators. And we also offer resilience for DNS responses. So we create monitors in DDI Central. If you see, we help you create monitors, and that monitors, when they are acting as a standalone monitor, it just monitors the host that you map it with. So it will make sure the host is up or down. It will inform you time to time, and you'll get the immediate alerts. But the true magic happens when you associate this monitor with a record. Let me show you how. When you create a DNS record, all you have to do is make sure that you associate a monitor along with it. So whenever you create one, you basically give the active and backup IDs. So with those active and backup IDs, the IPs, sorry, the monitor keeps on monitoring these IPs, especially when the active IPs go down. The monitor makes sure to alert you, and also it does not just wait for your response. It makes sure it takes over and makes the auto switch immediately. So the response for your DNS query is not shattered at any point. So here you, whenever you create a record, you make sure that you switch to the failover mode. When you create a failover mode, we'll ask you to enter the IPs that you'd like to add as active IPs and backup IPs. So make sure you add the IPs, and you associate the monitor that you created and the monitor module, and you can enable it. So this step is very crucial. Only with this kind of an association, the monitor will be able to take over and make that auto switch possible. And we also have DNS zone versioning. We also help you with do instant rewind and restore. So we have an option where you can view the previous versions over here, and in case if you feel the DNS records were a bit manipulated or something, you can just switch to the version that you'd like, and your DNS infrastructure will be completely aligned to the previous version that you've chosen. So we store around 10 versions over here. So you can choose the version you like. So yeah. So let me close the webinar with a simple picture. On the left is the previous system. The campus is moving, but it's slow because every change creates more work, more scopes, more VLAN tweaks, more DNS updates, more tickets, and more manual fixes. On the right is what changes when universities run DDI as one governed system. It's not that the campus becomes less complex, it's that you stop paying the complexity tax every day. You actually reach the finish line fast like a Ferrari than on a sluggish one. So, and that's the idea here. A productive campus LAN isn't built by adding tools, it's built by governing IP, DNS, and DHCP as one system. So we simplify it into three outcomes. With effective segmentation, you place devices where they belong by building department device type without multiplying work. The blast radius stays as small as possible and growth doesn't break the design. And with automation implemented, the IP and configuration assignment becomes policy driven. Leases, options, reservations, and DNS updates happen consistently, so churn doesn't create chaos. And with security stacks implemented, becomes part of the foundation where decisions happen at the point of identity and reachability. So you're not chasing incidents downstream, it travels along with your users, along with your services. So the takeaway is DDI Central isn't another tool in your pile. It's how you make the campus network scalable, governable, and secure without slowing down your operations. Thank you for taking the time to be a part of this webinar. Right after this session, you'll be directed to our downloads page where you can start your 30-day free trial. You can also visit our demo page where we have a live interactive demo up and running for you to explore and play around with. If you have any queries, please shoot us an email at ddi-support@manageengine.com. We'll help you with a POC or we'll help you with a personalized demo for you. So thank you.